problem definition. Afterwards, right, in the available templates, which template is more suitable to your problem, you select. Afterwards, draw flowchart, then do testing. If anything is missing, again go to the design algorithm, means do one or two modifications, again draw flowchart, continue. When 2, 3, 4 is completed successfully, means you have algorithm, not program, you have algorithm. Now verify your algorithm, means your logic is good logic or bad logic, verify. Means if it is taking less time, good logic. If it is taking more time, bad logic. So if logic is everything perfect, then go for the coding. Right? Implementation is the last part. But remember, everywhere testing is there. See, problem definition also you can do testing. After problem definition is over, total, right, there is a one team which will check every possibility covered or not. Right? There is a one team which will verify problem definition is everything okay or not. Right? Like that, everywhere there is a testing. Right? My required things only I return. Okay, fine. These are the steps to write the algorithm. Now some people are asking, okay, fine, sir. This is what we discussed in the last class. Then why you written once again? Remember everyone. As a computer science student, so from the neighbors are keep on crying. Yeah, once again come back. As a computer science student, as a algorithmic person, your goal is not all the things. Your goal is designing a algorithm, right? Analyzing a algorithm, designing a algorithm, analyzing a algorithm, right? These are the two primary things. As a computer science person, your major goal is not all the things. Major two goals are designing a algorithm, analyzing a algorithm. Algorithm, design and analysis. So algorithm, design and analysis, ADA. Or people used to say AAD. Or people used to say DAA. So our concentration is second step and fifth step. Remaining all also we can do, but these are the primary things. As a computer science student, your goal is how to design a algorithm, means learning all possible templates. And one more, how to analyze the algorithms. These are the two major things, right? So you may say that, sir, what about coding? That is also important. But if I want to say two major things, right? Second one and fifth one. Two major things are second one and fifth one. If at all three major things, second one, fifth one, sixth one also. However, there is no standard steps. I cannot say everyone will follow 6 steps only. Some people maybe follow 5 steps. Some people will follow 10 steps. But indirectly, directly, major things are designing a algorithm, analyzing a algorithm. That there is an algorithm subject also called as ADA or AAD, algorithm analysis and design, or design and analysis of algorithms. Right? So this is our concentration. This is our goal. If at all everything is okay, please comment in the comment section. Everything fine, sir. We can move to the next one. If at all everything is okay, please comment in the comment section. Sir, everything is fine, sir. Right? We will move to the next one. Please go ahead. Yesterday we done. So once again I explain, because I want to say that, right? I want to say that algorithm design, algorithm analysis, these are the two major things which we are interested. We are not interested other things. Other things also we can do, but major things are these two people. Our concentration in this subject. Second part, fifth part. Second part is we have to know how many templates are there, which is also called designing technique. How many templates are there? Next one, right? So after got to know all the templates, right? Next one is going to be how to analyze algorithm. Means how to find out time complexity, space complexity. We have to discuss that. So within few minutes we are going to that particular area, right? So I hope everyone is comfortable. Let's move to next. Yeah, now concentrate here. Concentrate everyone. Today's class, our target is analyzing algorithm. Analysis. Actually, our goal is design and analysis. Now, first I am going to analysis. So today's class is, in my opinion, right? Actually, today's class is, in my opinion, started just now. Today's class, in my opinion, just started now. Concentrate. Analysis. Right, analysis. So I'm just going one by one. What is the meaning of analysis? Finding time complexity, space complexity. So you can write that. What is the meaning of analysis? Right, I'm explaining. If any problem having is having more than one algorithm, if any problem is having more than one algorithm, then better algorithm decided by analysis. If any problem is having more than one algorithm, then better algorithm decided by analysis. So try to understand. Purpose of analysis is, if any problem having multiple algorithms, better algorithm decided by analysis. That is the purpose of, right, analysis. Better algorithm decided by analysis based on two parameters. One, CPU time. Two, one is CPU time. Another one is main memory. How much main memory it is taking? Main memory. Based on two factors. How much CPU time it is taking, how much main memory it is taking, how much CPU time it is taking. That is called time complexity. That is called time complexity. This is called space complexity. If any problem is having more than one algorithm, then better algorithm decided by analysis based on two parameters. CPU time, that is called time complexity, main memory, which is called space complexity. Right? Yeah. Anyone having any doubt? So remember, your concentration should be analysis. In algorithm, first chapter is analysis. So until now, some introduction is done. Right? In algorithm, first chapter is analysis. If any problem is having more than one algorithm, then better algorithm decided by analysis based on two parameters, CPU time and main memory. Because whenever a program is running, it will use the CPU. It will store data in the main memory. So whenever a program is running, how much CPU time it is taking, how much main memory it is using, that is called time complexity, space complexity. So remember, for any algorithm, time complexity is less, then it is the best one. Suppose a problem having 5 solutions, out of all of them, which solution will take less time? That means that is called less time complexity. That is the better algorithm. Right? You only say to do a particular task. Let us assume that we have 5 applications are available in the Play Store. To do one task in Play Store, we have 5 applications. Assume one application is taking 5 minutes, another one taking 5 hours, another one taking 50 minutes. You know very well. You know very well, right? 5 minutes one you will take. To do the same task, one person doing in 5 minutes, one more is 50 minutes, one more 500 minutes. Definitely people will go for 5 minutes only. So time complexity, space complexity, that is the reason. Right? A problem having more than one solution, better answer will be, better one will be decided by two parameters, CPU time and main memory space. Okay, I feel everyone comfortable. I feel everyone comfortable. Let's move to how to find out time complexity. Right? Time complexity. How to find out time complexity. How to find out time complexity. Right. Now see answer. See the answer. What is how to find out time complexity? Remember everyone? Remember everyone? Time complexity of any program. Time complexity of any program is equal to how much time that program compilation take. How much time that program running will take. Time complexity of any program T of P is equal to how much time that program will take for a compilation. How much time that program will take for running. So time complexity of any program is equal to compile time plus running time. This is the way how the time complexity will be calculated. Compile time plus running time. Compilation may be one time. Every program will be compiled in a lifetime only once only. But that should also be calculated. So time complexity of any program is equal to compile time of that program plus run time of that program. So next question is going to be compile time is based on compiler. Compile time is based on compiler. Compiler is a software. So remember, when you say software, it is a program. When you say software, it is a program. Remember, language of, when you say software, it is a program. So that program is written in which language, that matters. Language used to build that compiler or language of compiler. Suppose assume that software you written using faster language, then compilation time will be less. Suppose that software you build using the old language, using the slow language, compile time will be more. So what I mean to say is time complexity of any program is based on compile time plus runtime. Compile time is based on the compiler, which is a software. When you say software program, right? When you say program, in which language you are writing? Suppose that language is very slow language, compile time is more. Suppose that language is very fast language, compile time is, right? Fast language means compile time very less. So remember, time complexity of your program based on compile time plus runtime. Compile time is based on the compiler, which is a software, which is nothing but language of compiler matter. Language of compiler is a faster one, compile time less. Language of a compiler is slow one, compile time is more. So concentrate. Next one, running time of your program is based on, running means CPU, processor. Remember, processor is a hardware, right? So hardware. Suppose using that, I think nowadays M1, M2, M3. M1, M2, M3 nowadays. Previously P1, P2, P3, P4, Pentium, right? I5, I5, I7, I9, Intel. So remember what type of processor you are using, that matters. Suppose if you use M1 and M2 processor will be faster. If you use someone using M2, someone using M3, right, processor is faster. So to run your program, which processor I am using? Suppose using that i5, i7 faster, i7, i9 faster. So remember everyone, type of hardware matter, type of processor matters. Time complexity is based on two parameter, compile time, runtime. Compile time is based on the compiler, which is a software, which is nothing but language of compiler matters. Language of compiler is faster language, then compile time is less. Language of compiler is slow language. Slow language, then compile time is more. Next one, running time is based on the processor, which is the hardware. So type of processor matter. If you use the best processor, less time. If you use the worst processor, more time. So time complexity based on two parameter actually. Language of compiler, type of processor. These two things matter. These two things matter. Time complexity of any program based on language of compiler, type of processor. These two things are important. Okay, fine. Some people are asking, okay, fine, sir. Time complexity based on these two parameters. Language of compiler is what? Type of processor is what? Suppose language of compiler is assume. Language of compiler is assume that Java programming language, Java. Or maybe you can say Python, whatever it is. Language of the compiler is Java, and the type of processor, assume that M3. Then running time may be, then time complexity may be very less. Two best people if you take, then time complexity becomes very less. Two worst people if you take, suppose in the COBOL or Pascal. Language of the process, type of the processor is P1 assume, Pentium 1. COBOL language, which is the old language, type of the processor is a P1, which is the old processor, which may take more time. Time complexity of your program is more if you use the two things which are bad. Time complexity of a program is very less if you use two things which are good. So please careful. Right? I think, in my opinion, everyone is okay. Now, some people are asking, sir, that's fine now. That's fine now. Now, there is one more small description. There is a small discussion is there. Can you concentrate that also? Small discussion. Small discussion. Analysis will be two types. Analysis will be two types. Analysis will be two types. First one is, right? First one is going to be posterior analysis. Posterior analysis. Second one is priori analysis. First one is posterior analysis. Second one is priori analysis. Analysis will be two types. We are analyzing time complexity, okay. We are analyzing time complexity, okay. Right? Time complexity is based on two parameters. That is also okay. Now, analysis will be two types. Posterior analysis and priori analysis. Right? There are two types. What is the posterior analysis? What is the priori analysis? You can see one time. You can see one time. First point here. According to posterior analysis, if right, see everyone. According to posterior analysis, if I ask anyone, what is the time complexity of this program? According to posterior analysis, if I ask what is the time complexity of a given program, what they will do is, they don't calculate the time complexity of a given program, they will postpone it. If I ask anyone what is the time complexity of this program, what they will do is, whatever I am asking, they will postpone. What is the reason? If I want to say time complexity of this program, I have to know, right? I have to know in that particular computer, in which computer you are going to run this program, right? In that computer, what is the language of the compiler? What is the type of the processor? You have to say this. You have to find those. If you find those two, then only I can say what is the time complexity of a given program. According to posterior analysis, if anyone asks what is the time complexity of a given program, instead of giving time complexity of a given program, they will postpone it. Because to find that, we need language of compiler and type of processor. Without knowing those two, I cannot say what the time complexity of a given program. I cannot say. So that's what the posterior analysis. It is based on. Posterior analysis is based on. It is based on language of compiler. Language of compiler and type of processor. According to post-analysis, time complexity of any program is based on language of compiler and type of processor or type of hardware. But according to priori analysis, see this one. It is independent of language of compiler and type of hardware. So according to this analysis, if you ask any question what is the time complexity of a given program, he will give answer immediately. Type of processor is independent, but previous one is dependent. It is dependent on language of compiler and type of processor, but it is independent of language of compiler and type of processor. I hope everyone is comfortable. Okay, I'm thinking that you are absolutely fine. Can you see the second step? Sir, one is dependent, another one is independent. How, sir? How independent possible? You will get to know. According to priori analysis, it's independent of actual things. Second one is independent of actual things. Without those two, how can you find out time complexity? Second one is saying that I will find out. Second one is saying that my model is based on some other thing. My model is not based on the language of compiler and type of hardware. But first one is saying that my model is based on language of compiler and type of processor. So please careful. Okay, fine. Now, because of you are taking real things into consideration. Because of real things you are taking into consideration in the first model, the advantage with the first model is you may get the exact answer. Right? Let me write now. It will give exact answer. It will give exact answer, but because of he is not taking real things into consideration, it will give approximate answer. It will give approximate answer. It will give exact answer, but it will give approximate answer. It will give exact answer, but it will give approximate answer. Okay, that is also okay. Let's see the third step. One person taking real things into consideration, advantage, exact answer you will get. One person not taking real things into consideration, it will give approximate answer. Right? Can you go to the third step? Right? That is the advantage with the first model. First model advantage is exact answer. Second model drawback is approximate answer. But if you see the third step, see this one. The drawback with the first model is the drawback with the first model is, try to understand everyone. The drawback with the first model is time complexity of your program based on the actual things. If the actual things are changing, time complexity will keep on changing. What is the meaning? If I run this algorithm or if I run this program in some computer C1, it will take some time. If you run the same algorithm in some other computer C2, it will take some other time, because this computer to this computer, actual things are changing. Your language of the compiler may be C language. Your language of the compiler may be Java. Here may be M1 processor. Here may be M2 processor. Right? Maybe here maybe M3 processor. Maybe Pascal language. So what I mean to say is, the problem with the first approach is one computer to another computer, time complexity keep on changing. So let me write now. It will give different answer. It will give different answer from one system to another system. one system to another system. It will give different answer from one system to another system. In one system, if you run, algorithm is same algorithm. In one system, if you run 10 minutes time. If you run in another system, maybe 50 minutes. If you run in another system, only maybe 5 minutes. Because of real things you are taking into consideration, real things will change. Automatically answer also will change. Computer to computer, some small changes are there. So your time complexity also will differ computer to computer. Because of second one is anyhow independent. Second method is anyhow independent. So it will give same answer in every system. It will give same answer in every system. It will give same answer in every system because anyhow is independent. Anyhow it is independent. Anyhow it is independent. So please concentrate here. Right? Analysis. Posterior analysis, priori analysis. In the posterior analysis, the actual things you take into consideration. In the case of priori analysis, you don't take the actual things into consideration. Because if you are taking actual things into consideration, it will give exact answer, but it will give approximate answer. Because of you are taking actual things into consideration, system to system, actual things will differ. So time complexity also will be differ. It will give different answer from one system to another system. It will give same answer in every system. It will give same answer in every system. So analysis, right? Two types, priori, posterior. Name itself saying what are the posterior. If you ask what are the time complexity, you don't calculate whatever you are asking. Right? If you postpone it, you will try to calculate something else. Means the language of the compiler you want to calculate. Type of processor you want to calculate. Because without those two, this model cannot work. So that is the reason. And one more thing. Yeah, please let me know if anyone having any doubt. If anyone having any doubt, please let me know. Small doubt also there. Today's class is almost started here. Today's class is almost started from here. What is analysis? How to find out time complexity? Analysis is how many types? What is the difference between first analysis and second analysis? Let me know if anyone having doubt. Those people who are watching, please let me know your opinion. Sir, I have this doubt. Sir, I have that doubt. You ask me, I will help you. Everyone, whoever is watching, please let me know what doubt you have. If no doubt, say no doubt. If no doubt, say no doubt. Everyone. If no doubt there, say no doubt. Everyone. Everyone, please let me know if you have any doubt. Yeah, if you don't have any doubt, let's move further story. Posterior analysis and priori analysis. One is a dependent analysis, another one is independent analysis. First one is a dependent analysis. Second one is the independent analysis. Okay. Now concentrate, everyone concentrate. Everyone concentrate here. Everyone concentrate. Write down now. Priori analysis. Right, we will start the priori analysis. Remember, total industry follows. total industry follows, total computer science industry follows priori analysis only, not posteriori analysis. There are two analyses are there. Total computer science industry follows priori analysis. Because in the priori analysis, if you observe the priori analysis, it is an independent analysis. What I mean? Language of compiler doesn't matter. Next one, type of processor doesn't matter. If those two things are good, then only your program is good according to first analysis. But second analysis saying that those two things are immaterial. Language of the compiler doesn't matter. Type of processor doesn't matter. Right? So priori analysis saying that these two things are doesn't matter. You have a slow processor, then also no problem. You have a language of a compiler which is very slow, then also okay. This analysis saying that anyhow I am independent. I am independent of language of compiler, type of processor. I am independent. So you have a nice